Hey gang, here we are with the final exam review. I'm not going to do every single problem. I'm going to do kind of a handful of them just as we go through. That way you still have some that you can practice on your own. If you happen to hear panting in the background, that's my puppy dog. She's with me as I'm doing these videos. So here we go. Starting with Unit 6, we did vectors, and remember a vector has a magnitude and a direction. So we're going to look at both the distance, which is a radius of a right triangle, and the angle, which is, we use typically tangent inverse to get that value. So a couple of things. Component form of a vector looks like how we have it written in example 1. Vector f is 9, 40. So in this case, they just want 3 times f. Y'all, you can do that. Multiply each of those components, horizontal and vertical, by 3. Piece of cake. That was number 2, excuse me. Number 3 is do the opposite, so you change the signs. Piece of cake. Again, 4 and 5 are addition and subtraction. I'm going to show you 4 real quick. We want the opposite of vector A, so opposite of A is going to give us components of positive 9, positive 11, and then minus V, so that means plus a negative V. So go ahead and do the opposite of V also. V is 2, 3. So its components will be negative 2, negative 3 if I want the opposite of it. Now I have negative A minus V, or plus a negative V. I can go ahead and add those together, giving us 7, 8 as component form for that sum of those 2 vectors. Remember, the sum of any 2 vectors is called the resultant, whether you add or subtract. Boom. All right, 6 and 7. They ask us to get component form, and you're given 2 points for number 6. And then for 7, you're given actually 4 different ordered pairs, finding 2 component form of 2 vectors, and then subtract. So I'm going to hit 7 real quick so we can practice getting component form and rolling through the process. Remember, component form is the terminal minus the initial. Okay, so if I want vector tx, I have to take the components of point x and subtract point t. So tx is going to be negative 8 minus 6 for the horizontal or the x values, and 10 minus 8 for the vertical or the y values, giving us negative 14, 2 for vector tx. Okay, do the same thing for yz. So vector yz is going to have components of 1 minus negative 10, and then negative 9 minus 0, giving us vector yz as being 11, negative 9. And then when we subtract these 2 vectors, tx minus yz, negative 14 minus 11 is going to give us negative 25, and 2 minus negative 9 is going to give us 11. There you go, piece of cake. All right, let's scooch on to the next set, a little bit more complex info. So numbers 10 and 11 determine the magnitude and direction angle. So remember, our magnitude, it's the same thing as the distance formula, the square root of a squared plus b squared, or x squared plus y squared, whichever way you want to think about that. Okay, and then to determine the angle, so theta, we typically use tangent inverse of b over a, or tangent inverse of that y over x, vertical over horizontal. Okay, the thing that you have to be mindful of for these is making sure what quadrant you're in. Okay, so for number 10, the vector's components are 13, 12. Those are both positive, so quadrant 1. When you find your angle, yay, you're going to be done. In example 11, the components are 12, negative 35. That's quadrant 4 because I have a positive x and a negative y. Meaning, when I find theta, I have to do 360 minus that reference angle. Okay, so quick little review on that stuff. Let's go ahead and work through number 11, and we'll determine magnitude first. So that does look like the absolute value of vector k. That's the notation we use. We already have it in component form, so that would be the square root of 12 squared plus a negative 35 squared. You're going to pop that in your calculator, let it do all the work for you. So I'm putting that in my calculator real quick, excuse me. Plus 35 squared, and that gives us, oh, perfect, a magnitude of 37. So if I were to sketch this vector, go to the right 12 and down, here's vector K, and its magnitude is 37. Horizontal distance or component is 12, vertical distance would be negative 35. Okay, there we go. All right, and then determining the angle. So I want to know the angle at which gets me all the way around to the hypotenuse, or to where that vector actually lands. So when we do tangent inverse of negative 35 over 12, the horizontal over your vertical, so that is going to give us a value. Make sure that your calculator is in the correct mode. Don't forget that. We tend to forget to go back and forth between radians and degrees sometimes, so be careful with that. This actually gives us a negative 71.1 degrees. Okay, remember, that's our reference angle. That's what's inside the triangle, 71.1 degrees. Okay, so getting our angle going around, oops, let's rewrite that. That was our reference angle. So our true theta is going to be 360 minus that 71.1 degrees, which gives us 288.9 degrees. So this angle all the way around, getting us in quadrant 4, is about 289 degrees. You could round up to that. All right, there you go. Moving right along. Numbers 12 and 13, draw a diagram to illustrate horizontal and vertical components, and then find the magnitude of each component, okay? 14 and 15, draw a diagram of the resultant of the vectors, determine magnitude and direction angle. And 16 and 17 are find component form, magnitude, and direction of the angle. So they're all kind of asking very similar things. In 12 and 13, we are given the magnitude and we are given the angle. Okay, so I'm just going to pick one from each section and hit those, and that way you've got one that you can practice. So for number 12, vector T has a magnitude of 47 and a direction angle of 119 degrees. That means we are in quadrant 2 at 119 degrees. Okay, I know that its magnitude is 47. So I need to find the vertical and the horizontal components. So do not forget that in quadrant 2, your x is going to be negative, your y is going to be positive. All right. The other thing I got to remember is I need to use the reference angle. So what is the distance between 180 and 119 degrees? That's right. That's 61 degrees, okay? So when we set this up, we are going to, in order to find our angle, we've got that 61, cool. So to determine the horizontal component, I need x. That's going to be r times cosine of theta, which is our radius of 47 multiplied by cosine of 61 degrees. And that will give us 22.8, okay? To get the y value, the horizontal component, that is y multiplied by sine of theta. So 47 multiplied by sine of 71 degrees. Or excuse me, 61 degrees. 47 sine of 61 degrees. And that gives us 41.1 for its horizontal component, okay? So our answers for number 12, in component form, it should be negative 22.8 for the horizontal and positive 41.1 for the vertical. Remember, we are in quad 2. Okay, in example 3, you're in quadrant 3, or excuse me, in example 13, you're in quadrant 3. So you're going to have both negative x and y values for that one. All right, 14 and 15. Draw a diagram to find the resultant of the pair of vectors, determine magnitude and direction. Okay, so I'm going to hit 15 because that's where I am in this guy. Here we go. So finding the resultant, that just means to add the two vectors together. So vector t plus vector u, 12 plus 6 is going to give me 18, and negative 16 plus 8 is going to give me negative 8. Okay, if I were to sketch, vector t is in quadrant 4, and vector u would be in quadrant 1 because they're both positive, but like visually, so I'm going to go to the right 12 and down 16. There's vector t. From the end of vector t, I have to go to the right 6 and then up 8. Okay, so here is the addition of vector u, and then the resultant still puts us into quadrant 4, and the resultant again is at 18 comma negative 8. So determining its magnitude and direction, the magnitude of the resultant is going to be the square root of 18 squared plus negative 8 squared. So that value is 19.7. So that's the magnitude of that resultant vector. If we want to find the angle, we are going to do tangent inverse of negative 8 over 18. Remember, this is giving us only the reference angle, and that is because we are in quadrant 4. So that gives us a reference angle of negative 23.96. I'm just going to say negative 24 degrees. The answer key is going to be a smidge different. It'll be off a little more precise. That's okay. So if it's negative 24 degrees, I'm in quadrant 4, so 360 minus 24 is going to give us 336 degrees. There you go. Got that one. All right, that wasn't too bad. 360 minus the 24 gives us 336 degrees. The magnitude of the resultant is 19.7. Okay. Number 16 and 17, they want component form, magnitude, and direction. So we already did component form. It has to be terminal minus initial. I'm going to go ahead and do number 17. So terminal minus initial, 8 minus 7 is going to give me 1. And terminal minus initial, negative 6 minus negative 2, that would be negative 6 plus 2, would give me a negative 4. So that is component form of vector RS. Its magnitude is going to be the square root of 1 squared plus negative 4 squared, which is the square root of 17. That's a little bit bigger than 4. It's about 4.1, give or take. And then look at where your vector lands. It's 1, negative 4. Okay, so that tells me that we are in quadrant 4. We're going to get the reference angle from tan inverse and then subtract it from 360, just like we did in number 15. So we're going to do tangent inverse of negative 4 over 1, which is just tangent inverse of negative 4. Cool. That gives us about 76 degrees, negative 76 degrees. It's 75.9, blah, blah, blah. Okay. Again, this is the reference angle. To determine theta, the actual angle that gets us around into quadrant 4, we need to do 360 minus the 76, giving us 284 degrees. Yay us. All right. I don't know how long I've been doing this, but we are done with the vectors. We are scooching on. Ooh, these are a little bit out of order, gang. My bad. Scooching on to the polars, which is number 7. Or excuse me, unit 7. So in our polar graphs, the things that you want to make sure that you've got down pat is you can never have a negative radius. Okay, so if you get negative radius, you are going to want to go to the, basically you're adding pi, so you want to go diagonal from where the actual point is. And then the other part is we don't want to do a negative angle value. So in this case, we would add 2 pi And that is the same thing as determining a coterminal angle. Okay, so I gave you one of each. You're in quadrants 1, 2, 3, 4, hopefully. Okay, I lied. There's not one in quadrant. There's not one in quadrant 1 for these examples. I think I skipped a few. I sure did. Darn, there we go. All right, so we're back to numbers 19 through 22. Here we go. Number 19 is in quadrant 4. So if I go 1 negative pi over 4, remember negative pi over 4, its coterminal would be 7 pi over 4. So here's positive pi over 4 in quadrant 1. If I went down pi over 4, I'd be here at 7 pi over 4. That's why you're going to plot it with a radius of 1 and at that value. At 7 pi over 4. Like, these are a piece of cake. You just kind of got to remember them. Number 20, we're at negative 1, 5 pi over 6. So my theta is good. I'm going to be over here at 5 pi over 6. But instead of being at positive 1, I need to go the diagonal of that and land here in quadrant 4 at 1, 11 pi over 6. Okay, for 21, you plot that dude right where it is. Perfect. Okay, number 22, it's a negative radius and a negative theta. Heads up, these circles are all counting by pi over 12s. So when you look at quadrant 1, that first tick mark or that first radius coming out from pi over 2, that's 5 pi over 12 because it's really close to 6 pi over 12, which is pi over 2. So you can practice the rest of those, check and see how you did. And then we're scooching on. Now we are converting between polar and rectangular, going back and forth between these two. Some of these, y'all, are pretty darn easy. Really, really easy, okay? So if you look at like number 23, negative 1, 0, think about your unit circle. Negative 1, 0 is over here at 180 degrees or at pi, okay? So if I were to convert that radius, I'll still get the exact same thing. It's going to be the same, okay? So you could write negative 1 and then you could do pi, or you could do negative 1 and 180. That guy's a piece of cake. If we look at number 25, we have a radius of 3 and a theta of negative 150. Okay, I don't want a negative 150, so I'm going to add 360 to that and determine that I really want to look at 210. So a radius of 3, and I'm down here at 210 degrees. If you remember your unit circle, or you put that on your little cheat sheet, hello, your x value is negative 3 over 2, and your y value is negative 1 over 2. Okay, so you can use that information to get you the ordered pairs for that. And remember, we're using same thing we did with our with the vectors. X is going to be r times cosine of theta. Y is going to be r multiplied by sine of theta. If you need to determine theta, it's going to be tangent inverse of y over x. Or, in our case, the theta over the radius. Oh, there you go, piece of cake. So we're using all that same stuff. Use that information to get you these. These are really pretty easy. I'm going to let you guys practice those, see how you do with them. If you can make sense of it without having to really do the work and kind of visualize where it is on unit circle, saves a lot of time. All right, so in 27 through 30, now we're going from rectangular into polar coordinates, okay? So when I look at number 29, remember, these are my favorites. Square root 2 over 2 and a square root of 2 over 2, those are always pi over 4s. Every single time, they give us 45 degrees, okay? Think about what quadrant this is. This is a positive x and a negative y, so that's quadrant 4. So if I go down 45 degrees from 360, I'm at 315 degrees, or 7 pi over 4. Cool. I didn't even have to do any work, And I just visualized unit circle and reminded me, oh, hey, I'm going down this much and it's that guy right there, and boom, we're good. So I already know theta. I didn't do any work. It's 7 pi over 4. Now, could you do the work? Yes, you sure can. Okay, but you would have to get your radius first. Okay, well, how do we get the radius? The radius is the square root of x squared plus y squared. Okay, don't forget, when we do x squared and y squared values, those are your horizontal and vertical components of a vector, same stuff. So this one's going to look funky. I'll show it to you, but you know, you can pop it in your calculator or you can just kind of think through. So square root of the square root of 2 over 2 squared plus negative square root over 2 squared. Okay, well, if I square those, I'll get 2/4 for both of those values. So the square root of 4 over 4, well, what's the square root of 1? That's right, 1. So the radius is 1, and the theta is 7 pi over 4. So going from rectangular into polar, radius is 1. 7 pi over 4 is my theta. Boom, you're all done. Do the same thing for the remaining problems. They might look funky. If you can visualize, like number 28, visualize where is the point 0, -2. Okay, cool. How many degrees is that? What's the distance or the radius that you moved from the origin? Really easy if you just take a moment and think and don't stress yourself out. Whew, don't do that. Okay, I'm sorry that this looks crazy, but I wanted to put the equations of the polars along with their graphs on the same slide so we can make those connections. Okay, so looking at the equations of them, the easiest one to recognize is always your circle, because it's just r equals some value. Okay, so number 32 is a circle, and if you look at your graphs on your next page, number 37 is also a circle. They're actually the same thing. I didn't even catch that. Exact same. Cool. Love that. All right, the next one that I find easiest to recognize is going to be the rose curve, because your rose curve is always going to have sine or cosine and then some number with theta in parentheses. Okay, remember, if it's an odd number with theta, that is the number of petals. So for number 31, this is a rose curve with 5 petals. And if it's an even number, then with your theta, it'll be 2 times that number to get your petals. Okay, so looking at our graphs, number 42 is a rose curve, like that's easy to see, and then this one has 3 petals, which means whether it's sine or cosine, I'm not stressed about that right now. Okay, I know that it's going to be something 3 theta on the inside of that guy. All right, the remaining examples that we have are all limacons. They're all the same kind of stuff. Okay, so when I look at them, I'm looking at the A and B values. If A and B are equal, that guy is the cardioid limacon, which looks kind of like a heart. And that's because you're traveling from that point of reference the exact same distance one way as you do the other. Okay, so which graph gives us that? 39 has a loop in it. 41 is kind of like a funky circle. 40 bubbles in a little bit. Up, here we go. Number 38. This guy is a limacon. The cardioid limacon. Cardioid limacon. There you go. And that's because, and I blew that up so you could see it a little better. You can look real easily and see that you're going equidistant left and right from that origin point. Okay. Number 35. In this case, our A value is 6, our B value is 1. Our A is greater than 2 times our B, okay? So that one, when it does that, that is going to give you, pretty sure it is our convex limacon. It's trying to make itself a circle, but it kind of doesn't, like it bubbles out. It doesn't really have a really good dimple on there, okay? The next two that we have are the looped limacon. That one's easy to see. in number 39 because it makes that little loop on the inside? It sure does. And number 40 is a dimple. Yeah, it looks like a dimple on your face. It sure does. Dimpled limacon. Okay, so the difference between those, if you're doing the loop, then instead of just kind of bouncing equally, I'm going to have my A value be less than 2B. Or, I'm sorry, equal to 2B. Whoopsies. A equals 2B. So that guy is the looped. And then the other one, this is where our A is just greater than our B value, and that's going to give us our little dimple. It's going out just a little bit more. There we go. Okay, so there's your images along with the equations. You can kind of match them together and see. All right, we are on conic sections. Woo! Unit 8. We are plowing through this stuff. Again, I'm not doing them all. Some of these are super easy, and you guys need to practice a few on your own anyways. For 44 and 45, write the equation of a circle. You got to remember it's x minus h quantity squared plus y minus k quantity squared is your radius squared. 45 is too easy. 44, I'm going to practice with you so you can remember how to complete the square. We got to group the x terms together. X squared plus 8x plus half of the 8 is 4. 4 squared is 16. All right, group your y's. Plus y squared plus 28y plus half of 28 is 14. 14 squared is 196. That equals, move the constant value over, and then the two values you added to complete the square, 16 and 196, get added over to the other side of your equation as well. Okay. Remember, when we take our half value, half of b for the x's is 4. That gives us what goes in parentheses with our x. That's how we take x squared plus 8x plus 16 and make it x plus 4 quantity squared. Do the same thing for your y's. Y squared plus 28y plus 196 is y plus 14 quantity squared. Cool. Equals. Add all those constants. Negative 196 plus 16 plus 196 gives us 16. Boom, done. You can write the center as negative 4, negative 14, and you can determine the radius as the square root of 16, which is 4. Perfect. All right, when we are doing parabolas, yay parabolas, we loved these. You've been doing the little baby ones. Vertical parabolas, up and downs, always are going to have the y equals. There's no y squared term. For number 47, that one's just an x equals. So that is going to give us opening left or opening right. So in order to get the equation of this, I want it to be y minus k quantity squared equals x minus h for horizontals, and then you flip them around. Y minus k equals a multiplied by x minus h quantity squared for the other guys. Oh, I forgot my a on the horizontal. Let's fix that. A equals a times y minus k. All right, there we go. So I'm still going to group my x stuff together. X is positive on this side, the left side, so I'm going to go ahead and do x minus 35. I'm scooching the y terms to the other side of the equation. So that'll give me a positive 3y squared and a positive 18y. To complete the square, you have to have a coefficient of 1 for your squared term. So that would be 3, and then multiplied by y squared plus 6y. Go ahead and complete the square. Half of 6 is 3. 3 squared is 9. Cool. What do we add to the other side? We do not add 9. We add 3 multiplied by 9, which is 27. So x minus 35 plus 27 gives us x minus 8. That equals that leading coefficient, the 3 still stays. Y squared plus 6y plus 9 factors to be y plus 3 quantity squared. That's the equation, and you can get your vertex from the opposite of the h value and opposite of the k value to give us 8, negative 3. We know that this one is opening to the right because it's an x equals, and It's a positive leading coefficient, that positive A value. Okay. All right, so practicing sketching these are actually pretty easy because you only have a shift left or right or up or down, okay? You don't have both parts of the vertex. I'm going to fix number 49. You can do the same for 48. I'm going to rewrite it as x minus 4 is negative 1/2 y squared. So I can get the vertex to be, let's see, 4, 0. Put that point right there. And then use your A value, gang. Your A value is negative 1/2. Okay, this is horizontal, so instead of going down 1 and over 2, I have to do the reciprocal. So I'm going to go negative 2 over 1. So I am going to travel my A value horizontally 2 units to the left and up 1 and down 1. You can only use A one time. Rough sketch of your curve, boom, you're done. We got it. Opens to the left because it's a negative A value. All right, now we have ellipses and hyperbolas. These are so fun. Okay, how do we get the center, not the vertex, but the center? That's right, it's the opposite of whatever's with your x, and I'm doing number 51, which is 0, and opposite with your y, negative 1. There's my center. The rx and the ry, that is the distance you travel on the x, or horizontally from the center, and vertically from the center. So take the square root of 49, because that's under your x terms, which is 7. So from the center, I'm going to travel left and right 7 units. Okay. For the y values, it's the square root of 36. That's what's underneath the y. So I'm going to go up and down 6 units from the center to get my y values. There we go. We have an ellipse. It makes this cute little oblong circle. Makes an ellipse. There you go. You're all done. The major and the minor axes. So your major axis is going to be the biggest one. So how far did I travel across horizontally in this case is 14. And how far did I travel up and down? And that will give me the length of the minor axis, which is 12. So it's always 2 times that horizontal and vertical distance, whichever one's the bigger one. Okay, hyperbolas, similar process, but they are a teeny bit different because they have the asymptotes. Remember, they draw these little diagonal asymptotes for us. And then if the y is first, it is vertical. So I'll get, they look kind of like fighting parabolas, one above, one below, with the asymptotes in between. Or if the x is positive in first, like number 53, it'll be horizontal. I'm still going to have those same asymptotes, but I'll go left and right from the center point. Okay, let's do 52. So when we get our center, remember, opposite of h, opposite of k. Get those in the right order. We'll put them backwards as multiple choice because it's a silly mistake. So our center for this one is 0, 2. Be careful of that. There we go. From there, I need to look at the rx and the ry values. So the square root of 1 is 1 for the y's. I'm only going up and down, even though it says it's going to be vertical because the y is first and positive. I'm only going up and down 1 unit from the center. And then for my x's, rx is going to be the square root of 25, which means I'm going out 5 units left and right from the center. Okay, slope of your asymptotes. How are we traveling from the center to these little corner pieces where those x and y values meet? So there's my asymptote. Cool. We are traveling up 1 and to the right 5, or down 1 and to the left 5, up and over. Remember, it's always positive and negative. Once you get the slope of the asymptotes and you've rough sketched them, you can use that those vertice points and just follow the path of your asymptote and do a rough sketch. Okay, so in graphs, you're going to look for, does it have the right center, and did I travel the correct direction, the correct amount? Did I go up and down 1 unit and then sketch a vertical hyperbola? Alrighty, classifying the conic section. Remember our cheat. If A equals C, it is a circle. If A times C is a positive value, it's an ellipse. That means you're going to have like a 2x squared and then plus a 9y squared. If it's a circle, you would just have 5x squared and then plus 5y squared. Giving you examples so you can figure out 54 to 57 on your own. If you multiply A and C and you get a negative number, that's a hyperbola. That is the one that has the minus sign between the two terms. So you can have x squared blah 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 minus 16y squared. Or maybe you have negative 3x squared dot 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 and then plus 5y squared. Okay, so one of the squared terms is negative. And then if A multiplied by C is 0, that guy is a parabola. So you only have an x squared, or you only have a y squared. That's how you remember those. Put that in your cheat sheet. All right, our last part, this is Unit 9 that we just did. So synthetic division, long division, just be careful. Number 59, we can definitely do synthetic on it, but it's missing a term. So you have x squared plus 0x minus 19 being divided by your x plus 5. Pop out your negative 5 on the outside, 1, 0, negative 19. Remember, whatever that last number is the remainder, and that's got to be over top of whatever you divided by when you finish it, okay? Those are pretty easy to check. What I would say about the long divisions is take your time. I mean, you're not going to have a whole bunch of these. You might have one long division problem, but take your time with it. You're going to have plenty of time to do these, okay? So practice those 4. Come back and check your answers. If you still have questions, let me know, okay? For 63 and 64, partial fraction decomposition, I was looking at number 63, and when I looked at this one, I recognized that the denominator is a perfect square. It's the same thing multiplied by itself. You are not going to have one like that because the answers come out a little bit stranger than how we did them. So I want you guys to pick one from the notes to practice that you didn't do or that you know you did right and you can try again and get it. So you want it to look like 2x plus 7 over an x squared plus a 4x plus a 3, so that when you factor it, you'll have 2 different factors. I just want you to see it that way. So you'd put something over the first factor plus something else, the a over the b over your second factor. And remember, the order of those doesn't matter, okay? I'm going to work through the process of 64 so that you can see it, and then you can apply that to a different one. Practice something different from your notes for 63. So in 64, the denominator only has a GCF. So I'm going to rewrite that as x multiplied by x plus 4, and then I'll have a over x plus b over x plus 4. In order for everything to have the same denominator, I've got to multiply by that factor that is not in each of those pieces. And then we're going to rewrite. Got same denominators, cross them off. Love that. That's the best part. So negative 5x plus 8 equals a multiplied by x plus 4. So that's ax plus 4a. And then plus b multiplied by x, which is just bx. All right, what are we doing next? That's right, regroup, exclamation point. So I'm going to put the x terms in an equation. Negative 5x is ax plus bx, meaning negative 5 equals a plus b. Cool. And then I'm going to take the other terms, whatever I have left I didn't use. Oh, it's only the 8 equals 4a, and regroup those and make an equation. Cool. Solve for that one. Y'all got it. Piece of cake. 2 is the value of a. When you substitute that back into the other little equation you wrote, negative 5 equals 2 plus b, negative 7 equals b. You got everything you needed. Done. So we're going to rewrite it, negative 5x plus 8 over x squared plus 4x equals a 2 over x plus b negative 7 over x plus 4. Boom. Done. Got it. All right. Solving rational equations, kind of the same step that we just did a moment ago. We are looking at our denominators. Every term needs to be represented for our denominator so that we can cross it off. Yay. So number 66, x squared minus 3x just has a GCF. Same with number 65. It only has a GCF in there. So that means that the very, very last term, minus 1 over x, has to be multiplied by the x minus 3 in numerator and denominator. And then we can cross off the denominators and set numerators equal to each other. So 5x plus 2 equals x minus 6 minus 1 multiplied by that quantity of x minus 3. Be careful, y'all. Like, don't make silly mistakes with this. This is where it gets you every time. Negative 1 multiplied by x is a negative x. Negative 1 multiplied by negative 3 is a positive 3. Simplify all that. Combine your like terms. So 5x plus 2 equals just negative 3 because the x's are opposites. All right. Move your 2 over by subtracting. So 5x is negative 5 and x equals negative 1. How do I know it's not an extraneous solution? Well, x cannot be 0. It makes the function undefined. And x cannot be positive 3. It makes the function undefined. Those are from the common denominator, x and x minus 3. Okay, so this answer is good. Yay us. It works because it's not 0 and it's not 3. All right, as far as the graphs go, of course, you can use your calculator to help you get your graphs. You are going to have to be able to pick out intercepts, asymptotes, holes, domain and range, end behavior, increase, decrease, stuff like that. So we're just going to hit a couple of the highlights, make sure you got some of the stuff down pat. I'll let you guys practice the graphs. First thing I want to look at for each of these values is the y-intercept. Let your x equal 0, figure out the y. In 67, there's not a number, just a constant at the back end of the denominator. So you can put it there. So I get 6 over 0, which is undefined. Okay, so that means there is no y-intercept. Got it. In number 68, our y-intercept will be negative 4 over 12, which is negative 1/3. Plot it as best you can. Number 69, the y-intercept will be 0, negative 4 over negative 6, which is positive 2/3. All right. Next part is horizontal or slant asymptote. So 67, I have an x squared over 4x squared. They are the same degree, so it's y equals the division of the coefficients, 1/4. 68, top heavy. That is what we call a Dolly Parton. That's going to give us a slant asymptote. Okay. I personally would do long division for this example so I don't make a silly mistake, but you can do synthetic if you choose. Just remember you got to divide through by 4. So I'm going to do x squared. Yep, I'm putting in that 0, x minus 4, and here's a practice of long division, 4x squared plus 12. So off to the side, I need to see what's x squared divided by 4x. Okay, that gives me 1x over 4, so 1/4 x. Cool. Multiply that through to give us x squared plus 3x, and then I have to change the signs and subtract. The x squared terms eliminate, gives me negative 3x, bring down the next term. Okay, check again. What is negative 3x divided by 4x? That's right, it is negative 3/4. You do not have to go any farther. You have the equation of your slant asymptote. Y equals 1/4 x minus 3/4. Done. There is no horizontal. For 69, big bottoms, that is always going to be a horizontal asymptote at y equals 0. That's what you can do before you factor. Next, when you factor, I'm going to give you the rundown of this info. I'm not going to do the work. You guys practice it. If you have I'm just going to make something up. X plus 2 over. Okay. Everything in the denominator gives you the domain. It doesn't matter if it's a vertical asymptote or a whole. Okay. If it reduces, it becomes a whole. So for the one that I just made up, I have a whole at x equaling -2. The y value comes from the leftover factors, and I pop in that current x value, -2. -2 plus 1 gives me -1, and -2 minus 1 gives me -3. So the whole is at -2 positive 1/3. Okay, totally made it up. It's nothing that you actually have as a practice problem. All right, what's next? Anything left in the denominator is a vertical asymptote. So your vertical asymptote for this one is x equals +1. Anything left in the numerator is an x-intercept. If it's just an x, it'd be at 0. This one, our x-intercept will be at -1, 0. Okay, so our domain for this example would go -infinity to -2, -2 to 1, 1 to infinity. Great. Once you get all your stuff plotted, remember if you have, every once in a while functions are funky and they cross over the horizontal asymptote. If it does, just follow what it says and then sketch your graphs to match or to follow the path of the asymptotes. Then you can answer clearly range and end behavior. Remember your end behavior, if you have a horizontal asymptote, is going to follow that value. So for 69 and for 67, you're going to go to 0 for the end behavior for 69, and you're going to go to 1/4 for your end behavior for 67. Cool. After that, if it's a slant asymptote, the end behavior, one side is going to go to positive infinity, and then one side goes to negative infinity because you're sketching a line. There you go. Follow the path of that line. Okay. All right. The remaining problems are graphing piecewise functions. They're not hard, y'all. Just remember, like, I got open circles if it's a less than or greater than. I have closed circles if it has the equal to bar. Use your calculator to get points. And you want to pick the points that it tells you. So if it says greater than 3, I'm going to do 3, 4, and 5. I'm going to use those points, plot them in there, and see what happens and what I get for that part of a function. If it says less than, then I'm just going to use x values less than 3. I'm actually going to use the 3 or whatever number it tells me. I'm still going to put that there, but I would have to have an open circle. If you only have a number, that's a horizontal line. Cool. Or actually a line segment. So for number 71, I was kind of fiddling with at 3, -5, I'm going to have an open circle. I'll have closed circles going to the left. Okay. And then for 3 and up, I'm using that little parabola piece of the function, and there we go. So your point of discontinuity really is any open circle, but specifically this one is at 3, -5. Okay, sometimes you'll just have an open circle and you just list that. We've seen a couple of those weird ones. The very, very last problem that we would look at would be number 73 in absolute value. You want to get its vertex, and it's either going to be an open V if you have a positive A value and an upside down V if you have a negative A value. Okay, and you get to use that rate of change, that slope basically, to do both sides of your graph. So they're super easy. So your vertex for example 73 is going to be -3, -4. So we'll plot that point. And then we will use our A value. I'm going to go up 2 to the right one, up 2 to the left one. Do that a couple of times. Get the sketch of your graph. You got it. One side of your graph decreases across the domain to the x value of the domain. The other side of your graph will increase starting at that same point. So at your vertex, it's going to split your domain, increase and decrease. Domain's going to be everything because all the points are included. Your range is going to be from the bottom to the top. So look at the y value of the vertex. That'll either be the beginning of the range or the end of the range, depending on which way. Ours is at -4 and goes up to positive infinity. Great. Alrighty, so now, pretty sure that's it for that guy. We got everything. That's the bulk of the review. Thanks for sticking with me through all of this mess, and let me know if you have any questions, gang. We out.